All right, folks, please pay attention because your CBA is a week from tomorrow. And we really won't have a formal review. Your review are these little 2 questions per day on the warm-ups. You got to take these seriously. I got these from old CBAs. Okay, now, if you were stuck on number 1, guys, please listen, and you had no idea what to do something. What have we done with this for months? Factor it. Yes, it can. 2x and x. Now, 18 could be 1 and 18, 2 and 9, or 6 and 3. I think 6 and 3 is going to be the winner. If I put a 6 here and a 3 here, that would give me a 3x and a 12x. If this is negative and this is positive, that would work. So if x minus 6, if this one is the length, then what's the width? So the width would be 2x plus 3. We factored it. They already had told us what one of the dimensions was. They told us we were going to get this. We found the other one. Okay, so even if you had no idea what to do something. We've been factoring what polynomials forever. All right, now number 2 is a bit of a thinker, and they did put this one or one similar to it on the CBA last year. And you would have multiple choice on this one, which I think would help you work backwards through the answer choices. But you can also do this without knowing the answer choices. Think about this. Draw a picture. I know that all 4 sides added up equal 12x plus 4. They only gave me one side. They gave me the width, which is 2x plus 7. However, knowing this one side is 2x plus 7, the other one across from it is also 2x plus 7. How much is that so far? So we have used up 4x plus 14 of the whole perimeter that they gave us. So if I subtract the 2 sides I know from the whole perimeter, let me see what's left. What's 12x minus 4x? 8x. Now be careful here. What's positive 4 minus positive 14? That means that these 2 sides have to add up to a total of 8x minus 10. So the other dimension has to be 4x minus 5. That's the other dimension. There was one like this on your last CBA, I think. All right, so that's a little bit of your CBA review. Now, we don't have homework to grade. We are going to go over the test we took at the end. Let's go ahead and get our lesson out of the way. And I've really got 2 little mini lessons today. The first thing I want to talk to you about is vertical and horizontal lines. Okay, now, this really, usually I save this for when we get to linear functions. Folks, hush. But vertical and horizontal lines come up in a lot of stuff that we're going to be doing with domain and range and things like that. So we're going to go ahead and talk about just these 2 special types of lines. The first one I want to talk about is let's do horizontal. Now, this part I want you to watch, and I'll tell you what you need to write down. But I want you to understand how you can find the equation of a horizontal line. Okay, and remember, horizontal is like the horizon. That's a flat line, a completely flat line. So look at that line right there. That's a horizontal line, and it does have an equation. Every line has its own equation. To find the equation of a horizontal line, there is a whole process you can go through, but it's really easy on these 2 special lines. If you just look at maybe 3 points, and hopefully you'll start to see a pattern. Okay, so let's talk about this point right here. The coordinates of this point are what? 1, 3. To get to that point from the origin, I would go over 1, up 3. What are the coordinates of this point? 4, 3. Let's go backwards from the y-intercept. Negative 2, 3. What's this point right here? 0, 3. Do you see a pattern? The 3 is repeating over and over. Where is the 3? What position is it in? It's in the y position. A coordinate is an x number and then a y number. So guess what the equation of this horizontal line is? Y equals 3. You cannot just tell me 3, and you certainly can't tell me x equals 3. It's y equals 3, because every y value on that line is a 3. Because every y value is a 3, that's why. Some kids look at the y-intercept. What's the y-intercept? 3. All of the y values on that line are 3. Not just the y-intercept, but all of them. Okay, what's the equation of this line then? Not just 1. Do not tell me 1. Y equals 1. What's the equation of this line? Not just negative 3. Y equals negative 3. Okay, it does matter because an equation has to have an equal sign, and in this case it's got to have a variable and a number. And I'll tell you, and we'll go look at vertical lines in a minute and you'll see the difference. But you cannot just tell me negative 3 because I don't know if the y number is a negative 3 or the x number is a negative 3. So you got to tell me which one. Now, here is something else. Please listen to me, write this down, put a star by it, burn it into your memory because every year this question comes up. Are you listening? And I have kids who act like they've never heard of it before, or they want to ask me what I'm talking about, or they don't understand the question. It's a very simple question. Look at this line right here. It's a horizontal line, and it's a special horizontal line. That's called the x-axis. The x-axis is a horizontal line, and everything that's true for horizontal lines is true for the x-axis. What's the equation of the x-axis? Y equals 0. So sometimes I'll ask this question on a test. I'll ask, what's the equation of the x-axis? And I'll have somebody ask me, they'll bring the test to me, what's the equation of the x-axis? And they'll ask me, what x-axis? Well, the x-axis, the only x-axis. You would not put 0. You would put y equals 0. So it's kind of backwards of what the name implies. The x-axis, the equation of the x-axis is actually y equals 0. Look at some points that are on the x-axis. This is 0, 0. Look at this point right here. 1, 0. Look at this point. 2, 0. 3, 0. What do they all have in common? They all have a y value of 0. So any horizontal line, the equation of any horizontal line is always y equals, and then you just fill in the blank for what number it equals. But it always has to start out y equals. Here's y equals 5. Here's y equals 4. Here's y equals 2. Here's y equals negative 1. What is this? Y equals 0. So the x-axis, it's a special line because it helps form the coordinate plane, but it's just like any other horizontal line. It's y equals 0. All right, let's talk about vertical lines. Vertical lines. You didn't have to draw all those little lines I was drawing, but I do want you to know a horizontal line is always going to be y equals something. Y equals a number. I also wanted you to know the x-axis is y equals 0. The one and only x-axis has an equation of y equals 0. Okay, vertical lines. These are the lines that I call outlaws. When we get into linear functions, you're going to realize these don't follow any of the rules. All lines start out y equals. This kind of line does not start out y equals. This kind of line starts out x equals. All vertical lines start out x equals. It's always x equals a number. These are also the only lines that are not functions. In a minute we're going to talk about the vertical line test. This fails the vertical line test. Okay, so look at this. I do much better drawing horizontal. Look at this line right here. That's a vertical line. Vertical goes straight up and down. If I looked at some points on this vertical line, let's just talk about some of the points on this vertical line. This point right here is 2, 0. Look above it. What point is that? 2, 1. What's this point? 2, 2. Let's go down 1. This is 2, negative 1. Do you see how they all have number in common, which is a 2, but it's not in the y position anymore. It's in the x position. So the equation of this line is x equals 2, because every x value anywhere on that line is a 2. The y values change, but the x value always stays a 2. Does that make sense? Okay, so what's the equation of this line then? Not just negative 2. X equals negative 2. What's the equation of this line over here? X equals 6. So a vertical line always starts out x equals. Always. It's an outlaw line. Now, the y-axis is a very special vertical line. It's special because it defines the coordinate plane for us. The coordinate plane is made by the x and y-axis intersecting. But what is the equation of the y-axis? And don't ask me what y-axis. The y-axis. The only y-axis. What's the equation of the y-axis? X equals 0. What's the equation of the x-axis? Y equals 0. What's the equation of this line right here? Y equals 3. What's the equation of this line right here? X equals negative 2. So the equation of horizontal and vertical lines, it's very easy to find their equations. And we're going to use that later on into this week's lessons. Okay, now, let's take a trip down memory lane and talk about domain, range, relations, and functions. This is the boyfriend and girlfriend thing. All right, relations and functions. You will have several definitions, 4 definitions you got to write down. The first one is going to be relations. Okay, so here are 4 definitions we're going to start with today. Let's start with a relation. So write down these definitions, please. A relation is, so the vocabulary word is relation, and the definition is, it's a mapping or pairing of input values with output values. When you're putting together an input and a matching output, automatically you have created a relation. It doesn't have to be numbers, it could be anything, but if you are pairing inputs with outputs, that's all it takes to be called a relation. Pairing inputs with outputs, you are a relation. And it can be done by mapping, it could be done in a just by showing you points on a grid. It could be done by listing points. It could be done by showing you a graph, and we're going to talk about all those examples. If you've got inputs and outputs, that is a relation. Now, some relations become functions. This is what a function is. A function is a relation, which means it's pairing inputs and outputs. So it's a relation in which each input has exactly one output. And that's important. The input values can only be paired with one output value. So sometimes you're going to be given either a point or a picture or a mapping or a graph or a t-chart, and you're going to be asked, is this a function? And you're going to have to use this definition to determine if it's a function. I distinctly remember when I was in 9th grade taking algebra, this part really confused me. So when I started teaching it, I had to really think about this. And the easiest way that makes sense to me is in a function, the x's cannot repeat. You can't have 2 x values that repeat in a function. The y values can repeat all over the place. That's perfectly fine. The x values cannot. Okay, now domain and range. 2 other vocabulary words you got to be familiar with. Some domain and range questions are like a gift. So if you get a super easy domain or range question, you don't want to miss it. Domain is just the input values. That's usually for us, we usually call those x values. It's what you put into a function. It's the independent, it's what goes in. It's the input. And in most cases, when we're talking about functions, it's going to be the x values. And you just have to memorize that. Domain is x values. Range then would be The y values, the outputs, the answers. The range values are kind of like the answers to the function. It's what you get out. You put in an x value, you put in a domain value, you do your math to it. It spits out an answer. That's the range. The answer is the y values, the output values, the dependent values. The y values can repeat all over the place. X values cannot. So this should be a review from last year. Y'all remember this? Okay, now here are different ways to show you functions. This page right here is just showing you, they might give you a set of ordered pairs or to show relations. They might give you a picture of a graph. They might give you what's called mapping or a table or a t-chart. Those are all different ways that they can represent a relation. Sometimes they'll give you those things and ask you, is it a function? So let's look at these. Here's a set of ordered pairs. Is this a function? It's definitely a relation, but is it a function? No. This particular one is not a function. You know why? The negative 2's are trying to repeat. I've got x values there trying to repeat. The x's cannot repeat. It doesn't matter really what's in the y values. Look here. Do you see how the 1's repeating? That's okay. The 1's can repeat. The y values can repeat. The x's cannot. So this is not a function. They might show you a graph, and we're going to talk about in more detail in a second the vertical line test. Y'all remember Miss Wynn telling you about that? If you run a vertical line across the picture, it should only touch once. If it only touches once, it's a function. Let me give you a little hint. Almost all lines are function. The only kind of line that's not a function? Vertical line. Lines aren't curved. Lines are straight. Okay, look at this mapping. Is this a function? The mapping is the ones that confused me the most, because sometimes two arrows can, it depends on if you're going from the x's to the y's or y's to the x's, but this is not a function, and this is how I would do these. I would write them down as points. Do you see how 6 is going with s and 6 is always also going with t? Do you see how the 6 is trying to repeat? Not a function. Not a function. Is this table of values representing a function? Yes. How do I know? None of the x values repeat. So yeah, that one is a function. All right, let's look at some more examples. This is the one that I think Miss Wynn has told you guys about. Like, see, the x's are faithful. Once an x value gets lined up with a y value, it never goes with another y value. However, the y values can repeat. Like right here. It's okay that, oh wait, this is not a function, I'm sorry. The reason why this one's not a function is because the x's are repeating. But it's okay for the y's to repeat. All right, is this mapping a function? Yes. Because look, if I wrote it out as points, you've got a q with 4, okay, an r with 5, an s with 6, and a t with 6. Is that allowed? Yeah, the y values can repeat. That's okay. That is a function. All right. Sometimes on the CBA, they'll give you one super easy problem. You don't want to miss it. If they give you a list of points and ask you to, first of all, they might ask you, is it a function? Is this a function? Yes. The x values aren't repeating. Then they might ask you to list the domain of that function. That's just the x's. What is the domain of this function? -1, 2, 1, 8, and 9. That is the set of domain values. The most confusing thing is they might put them in numerical order, not in the order it was given in the problem. But those are the domain values. What are the range values here? 2, 51, 3, 22, and 51. And 51 appeared twice. I don't have to write it twice. Do you see how the 51 repeated? Is that okay? Yeah, it's still a function if the y value repeats. And if it is repeating, they usually only write it once. All right, so domain and range is pretty much just memorizing. What are the domain values of this relation? -5, 21, 11, 81, and 19. Is it a function? Yes. What are the range values? 6, negative 51, 93, 202, positive 51. So if they ask you for a domain and range, that should not be difficult for you. You just have to memorize. Some kids get them backwards. So you got to remember, domain goes with x's, range goes with y's. All right, real quickly, just to show you examples of things that are functions when you're mapping. These are two examples that are functions. Because it's okay that the 6 is repeating. S is going to 6, T is going to 6. That's perfectly fine. Same thing here. The C is going to 3, and the D is also going to 3. The Y's can repeat. That's perfectly allowable. So these are functions. All right, let's look at an example of mapping that's not a function. Look at this one. Why is this one not a function? Right here. The S is trying to go with 6, and the S is also trying to go with 7. That's not allowed. Why is this one not a function? Because of the C's. The C is trying to go with 3, and the C is also trying to go with 4. That's not allowed. So is this one in red a function over here? Why not? Because this right here, the 6 is going with negative 1, and it's also going with negative 7. That's not allowed. All right, this list of coordinates here. Is this top one a function? Oops. It is a yes. I just can't get it to unclick. Is the bottom one a function? Why is the bottom one not a function? Because of the negative 2's. X's can't repeat. It means it's a relation, just not a function. Okay, is this t-chart a function? Yeah, this is an example of one that is, because look at the x values. They don't repeat. Is this one a function, the blue one? No, because of the 1's. Is this one a function down here then? No, why not? Because the 2's are repeating. Okay, here let's look at some pictures. The vertical line test. If you can imagine an imaginary vertical line, like your pencil, moving across the picture, it should only touch the picture once. If it crosses the picture more than once, then it fails the vertical line test, meaning it's not a function. So let's look at some pictures. Is this a function? Yes. If you moved a vertical line across this picture, it would only touch the graph 1 point at a time as you move the vertical line across. That is a function. Now, look at this. Okay, that's not a line though. That's a parabola. All right, so this is crossing it how many times? Twice. Guess what's happening here? The x values are repeating. Like this point would be at 2, 4, and this point would be at 2, negative 3-ish. The x's can't repeat. That's not a function. Any parabola is a function. Whether it's opening up or opening down, those are always functions. And please look at this, because sometimes the pictures they give you on the CBA are they're not very good quality pictures. And sometimes you have a super skinny CBA, a super skinny parabola where it looks like the arms are almost going straight up, but it's really continually moving out. So even if it's a super skinny parabola where it looks like the arms are almost straight up and down, that is a function. Okay, so it does get a little tricky sometimes. All parabolas are functions. All lines are functions, because it should only cross once. I'm sorry, let me back up. Not all lines are functions. Almost all lines are functions. Guess what the only kind is that's not? A vertical line. That's the only kind of line that's not a function. Imagine crossing a vertical line across this picture. What happens when I get right here? You're touching every single point at once. Okay, is this a function? Yes, because if I ran a vertical line across it, how many points would I touch at once? Just one. All right, is this a function? Nicole, look up here. You got to know the difference. Why is this not a function? It repeats right here. It should only touch the picture or the points or whatever 1 point at a time. So that would not be a function. All right, we will practice more of that tomorrow, and we're going to do some trickier domain and range questions tomorrow. So for today, you should understand the difference between a relation and a function. On a function, what happens? X's can't Repeat. Okay, you should also know what domain is. Domain is the x values, the inputs, the independent. Range is the y values, the output. Also, if I gave you a picture of a vertical line or a horizontal line, you could tell me the equation. What's the equation of this line right here? X equals -2. What's the equation of this red line right here? Y equals +2. What's the equation of the x-axis? Y equals 0. What's the equation of the y-axis? X equals 0. So if I ask you to give me that, you're not going to look at me like you've never heard of that in your life, right? Okay, now your homework really has nothing to do with this. I want to make sure you practice solving quadratic functions. Your homework is page 226 to 37. Now please listen carefully. You will have a quiz this week that's just solving quadratic equations. I don't care on today's homework whether you do it by factoring or whether you do it by the quadratic formula. But please listen and hear this part. On the quiz I give you, I will probably make you use quadratic formula at least once. Some kids like it better. Some kids do the whole thing on quadratic formula, and that's fine with me too. Now, on this assignment, factoring will work for all of them. They are all factorable. Quadratic formula will also work for all of them. Are you listening? On these problems, just on this homework assignment, they're all rigged. So if you're a quadratic formula person, you should get perfect squares inside that radical sign. If you get anything that's not a perfect square in there, like if you get the square root of 20 or something like that, then you did something wrong. Because on tonight's homework, they can all be solved with nice answers, not necessarily whole numbers, but nice answers by factoring or quadratic formula-ing. No.